Today we are looking at Compass, a framework designed to help language model agents solve long-horizon tasks. These are problems that cannot be answered in one neat step. They require searching, using tools, checking evidence, recovering from mistakes, and deciding when to stop. The central claim is simple. Better reasoning is not only about a stronger model, it is also about managing the context that the model sees. The motivation starts with a familiar failure mode. A single React-style agent keeps appending every thought, tool call, and observation to one growing history. At first, that history is useful, but over many steps, important constraints get buried, old errors distract the model, and the agent may hallucinate or stop too early. Human-in-the-loop multi-agent systems can help, but they require manual intervention. Compass aims to automate that oversight and context cleanup. The paper separates two kinds of reasoning. Tactical reasoning is the step-by-step work. Choose a search query, call a tool, read the result, and continue. Strategic reasoning is higher level. Ask whether the current plan is still sensible, whether the agent is looping, whether evidence is contradictory, or whether the answer is already verified. Long-horizon tasks fail when these two jobs are mixed into one overloaded context. Compass implements that separation with three specialized components. The main agent performs tool use and local reasoning. The meta-thinker watches progress asynchronously and intervenes when it detects a loop, contradiction, failed plan, or completion signal. The context manager turns messy trajectories into concise briefs for the next round. Together, they form a dual-loop system. One loop executes the task, while another loop refreshes strategy and context. A Compass run begins with the user query and an initial plan. The context manager creates the first brief. The main agent then works through a React-style inner loop while the meta-thinker monitors the trajectory. If the meta-thinker triggers, the system pauses to decide whether to persist, pivot, verify, or stop. The context manager then writes a refreshed brief that carries forward verified evidence, corrections, open questions, and next actions. The strategic part can be thought of as replanning over an evolving context. Instead of assuming the original plan is always valid, Compass asks whether the next trajectory should change based on what has happened so far. That is what allows the agent to recover from dead ends. A narrow search query may only need persistence, but a broken source, repeated failures, or conflicting evidence may require a pivot or verification step. The headline results are consistent across three difficult benchmarks: Gaia, BrowseComp, and Humanity's Last Exam. With Gemini 2.5 Pro, Compass reaches 35.4% on BrowseComp, 67.8% on Gaia, and 31.7% on HLE, outperforming single-agent and multi-agent baselines. With Gemini 2.5 Flash, it also improves over comparable baselines. The largest gains appear on BrowseComp, where many tasks require sustained web navigation and cross-source verification. Accuracy is only part of the story. The authors also measure strategic behavior: when to persist, when to pivot, when to conclude, and when to keep searching after a likely wrong answer. The chart shows that single agents often persist too blindly, while some multi-agent baselines pivot more but lose steadiness. Compass achieves a better balance because the meta-thinker detects strategic risks and the context manager keeps constraints visible. The paper also explores efficiency. The context manager is more structured and deterministic than the other agents, so the authors train a smaller specialized model called Context 12b. It learns to produce concise briefs from trajectories and meta-thinking notes. Supervised fine-tuning teaches the format, and preference optimization rewards summaries that preserve success while reducing tokens. The result is a context manager that approaches larger model performance with substantially lower token use. For robustness, Compass can also use test time scaling. The idea is to sample multiple alternatives during inference and synthesize a final answer or plan. Full pipeline sampling gives the strongest accuracy gains but costs the most tokens. Sampling only the meta-thinker or context manager is cheaper. The results suggest a practical sweet spot around 2 to 4 parallel samples where accuracy improves before costs grow too steeply. The takeaway is that long-horizon agent failures are often context failures. A powerful model can still lose track of constraints, repeat bad searches, or stop before verification. Compass addresses this by making oversight and context organization first-class parts of the architecture. The broader lesson is useful beyond this system. Reliable agents need not just better tools and larger models, but mechanisms that decide what to remember, what to question, and when to change course.